I want to introduce our keynote speaker for the day, John Seely-Brown. John was the head of the head of Xerox PARC for quite a while. John has been writing books that, as I said earlier, and talking and writing about the things that are driving the business dynamics and the economic dynamics that are driving many of the trends that are shaping what happens in IT. I think, and as I've said, there have been several catalysts where I quoted his books and recommended you read them, and we thought, well, what a novel concept to have him come here and actually talk about it. So with that, I'd like to introduce John Seely-Brown and welcome him to the stage. Thank you very much. I look forward to talking to all of you this week. Thank you very much.
Thank you. Good afternoon. We have a lot to cover. Jamie, the new normal is here. It's been here for some time, I agree with you, but getting our heads wrapped around this is a non-trivial task. So I want to ask the question, how do we actually think about thriving in a world of constant flux? And it's the word of constant flux I want to focus on. I'm going to claim and end the morning or the afternoon, with kind of a talk of the major shift before us, the shift from a push-based economy, which characterized everything we did in the 20th century, to the 21st century of a pull-based economy. The bottom line, though, is many of the things that made us really successful in the 20th century actually get in our way of being successful in the 21st century. So Jamie, some things are okay to have them walk out the door. It creates more room to think through this game in a fundamentally new way. But I want to start with a belief. The belief is that our challenges are both fundamental and substantial. We really have moved from a world of equilibrium, pretty much the last part of the 20th century, to a world of constant disequilibrium, which I think is the underpinnings of what this new normal is about. If this is true, this means that our business models, our ways of working, our ways of creating value, and our ways of innovating must really be seriously rethought. But sure, why do I say that? Haven't we done pretty well? Aren't we recovering pretty well? More or less, not totally. What's the big deal? Well, maybe our recovery today, and in fact the crisis we just came from, is covering up something much more fundamental that we ought to get to the root of to understand what that is about, because that's going to come back, I'm going to claim, to dramatically influence our pathway forward and how we want to think about IT, how we want to think about cloud computing, and a whole bunch of new aspects of a new dimension of agility to play in this new game. But why do I say this? I want to just quickly walk through 4 or 5 graphs that start to reveal and unpack what may be the deep structure of the problems we're facing. Not the current fiscal crisis, but let's dig underneath that. For somewhat ironic reasons, John Hagel and I started out to look at, not looking at how have we done over the last 45 or 50 years in terms of return on equity, which is what almost all of our economists look at. We wanted to look at return on assets, hard assets, or add to that intangible assets if you wish. Why do we do that? If you actually look at return on equity, we're capable of playing an infinite number of very cute off-book games having to do with debt financing. And we're seeing the results of that in Wall Street in the last couple of years. Suppose you look at the one thing you can't goof around with. Suppose you look at how are we doing relative to the hard assets. Well, if you start off there, the story looks surprisingly grim. Since 1965, over 20,000 companies in the United States, which we've been able to kind of analyze now, basically the return on assets have dropped almost linearly 75%, and there's zero indication that this game is changing. In fact, if you believe in linear extrapolation, which I'm sure very few of us here do, in about 2020, return on assets go to zero, and the nation becomes bankrupt. curious fact is that in 2020 to 2023 is about the same time that our debt equals our GDP. These are unrelated, but it turned out to be kind of an interesting coincidence, perhaps. But after all, that last graph was an aggregate. Suppose we tease it apart. Suppose we look at the bottom quartile companies and the top quartile companies and see how they do. Well, guess what? The top quartile companies are also going down. They're going down at a slightly slower rate, which means, of course, the gap between the bottom and the top is increasing. But no one, on the average, in the top quartile is winning this game. We are still headed down. One more very disturbing piece of data is we look at the topple rate. If we look at, for example, a company that starts off and finally does really well enough to make it in the S&P 500, how long can you expect a company that just made it in the S&P 500 to last? Originally, it used to be around 75 or more years. It's now down to approximately 10 or 15 years, and our analysis suggests it may go down to 5 years. The topple rate of 5 years, think about it. An interesting parenthetical thought is, if the topple rate is that great, why are we paying CEOs so much? It's supposed to be a joke. But against this, let's look at something a little bit strange. Labor productivity, because of IT to a large extent, has been going up. That's curious. Labor productivity has been going up, but ROA is straight downhill. What is causing this gap? What is causing this? Yeah, why? A partial answer. In fact, power has shifted to the customer. So customers are getting a slightly better deal. Brand loyalty is diminishing. Intense global competition, having somewhat to do with public policy, is increasing. And perhaps the single most surprising result we've been able to show by factoring this data is that creative talent is getting more of the rent than ever. So the ROA has been going down, but creative talent has been getting more of the rent. So the rent has been distributed across these things, and that seems kind of plausible, and that's definitely a part of the new normal. But maybe something much more fundamental is going on here that actually builds on Jamie's fundamental insight about the role of infrastructures. Let's look at the 20th century. Let me go back to Alfred Chandler, probably the greatest historian on business and finance that ever existed. He made the interesting observation that basically we build our organizational architectures to get leverage out of the existing infrastructure we live in. He was not talking about IT particularly. He said every society has a fundamental infrastructure. The 20th century, our infrastructure was basically transportation. Roads, planes, cars, trucks, and so on and so forth. An interesting property of this infrastructure is it follows an S-curve. By the way, every past major infrastructure that the civilization has ever seen has followed an S-curve. There's a short period in which it comes into being, it gets installed, and then it levels off. Roads haven't changed much, cars haven't changed much in the last 50 years, airplanes haven't changed much, and so on. And so you had this sense of a big jump, of a punctuated move, and then you have beautiful stability. And this stability leads us to be able to predict things, which we're going to come back to having to do with database structures later on. And it leads to the notion that perhaps the fundamental underlying strategy of nearly all our corporations is to think about how do you actually get leverage out of scalable efficiency. As we know from the experience curve of Boston Consulting Group, basically the more you do something, the better you get. This is across virtually all industries, where we can show how you go down those learning curves or experience curves, and you get better and cheaper produced products. In order to make that scalable efficiency happen, you obviously have to have predictability. So you got to be able to build more and more of this stuff, and then, by the way, store it up and transport it over this brilliant infrastructure of the 20th century. And this leads to our organizational architectures and into MRPs, ERP systems based on hierarchy control, minimizing variance, and of course the very basis of virtually all the organizational routines that define our particular firms. And I spare a comment on Ronald Coase at the moment. But today, the game is different. I'm going to argue for the very first time, probably in civilization's history, is what we now have is a new type of infrastructure, not just permeating corporations, but permeating everything we do, how we live, work, learn. And this really is basically an exponential curve comprised of a whole rapid sequence of punctuated evolutions that show no sign of slowing down. Yeah, Moore's law may be slowing down, but we know what we do in this room. We change the algorithms. We actually go to multiple cores, many cores after that, so on and so forth. We'll show you an example later. But the fact is that the underlying structure of this new normal is driven by this unrelenting advancement, which is basically causing one type of disruption after another, and is causing tremendous disequilibrium in almost everything we do. I like to say that 2 years ago, it was cloud computing that changed the game. This year is probably going to actually be graphic processing units and how they actually play out in the clouds later. We'll go into that. But this game is constantly changing, and every one of us in this room and through this week, you will get to marinate in some of these types of changes. But what this really suggests is we're living in a world of rapid change where the half-life of a given skill or knowledge assets is actually shrinking. The half-life may be getting down to, in terms of human skills, almost like 5 years, where it used to be 20 years, 30 years, 40 years. The predictability of the future is increasingly uncertain, especially as these skills and assets start to shrink. And we want to argue that the simplest but major, most fundamental transformation that's happening is we're shifting from a world in which we were taught how to protect and husband stocks of knowledge and other types of hard assets in the company. And we know how to do that. We also know a tremendous amount about knowledge management and all this, to a whole new world, in this world of constant flux, shrinking half-lives of most of our assets, knowledge assets and skills, to a world of flows. And the new game in town is how do you figure out how to participate on the edge of those flows? How do you participate in the creation of new knowledge constantly? And by the way, this new knowledge isn't something you can wrap up in a database, because much of it is tacit. We hold it in our experiential basis initially. And then what are the new modes of value creation in this world of kind of participating on the edge of these flows? This actually suggests quite a different purpose of the firm. The purpose of the firm may now be, how do you accelerate the growth of new talent, new knowledge, as opposed to how do you preserve and simply exploit old knowledge. It also suggests that maybe we have to rethink how to break the back of the Red Queen effect. The Red Queen effect says basically, I'm from Alice in Wonderland, I'm running faster and faster just to stay in place. By the way, most of us would be happy if we were running faster and faster just to stay in place, because most of us are running faster and faster and just kind of losing a little bit. This is not surprising. It's not surprising because, after all, the experience curve, which drives most of our underlying corporate strategies in the 20th century, was a diminishing returns curve. You could start and move quickly down that learning curve, but to make each equivalent incremental advancement, you have to work that much harder as the curve starts to flatten out. The obvious question is, might we be able to take that curve and flip it on its head and transform it into an increasing returns curve, which we're going to claim is the way to play in the new normal. And we're going to call this, how do you move from experience curves to collaboration curves, where you harness network effects so that the more people that participate, the greater the potential returns. Now I'm going to go through 3 quick stories and then jump to the infrastructures that enable us to play this game in a fundamentally new way, having to do with different ways to look at cloud computing. The 3 stories are looking at how a small set of people working together in a cohort group in a firm could use some of these ideas, to how developers have used these ideas, to basically how entire ecosystems are now being refactored and rethought to play a different kind of game. Story 1, Skadden. Skadden is one of the biggest and one of the, I would say, most conservative law firms in the country. They work out of New York City. Every year they bring in associates, kind of an intern program, put them to work. 2 years ago, they brought in a group, and all of a sudden, they started noticing something strange. This cohort group started to get cases solved in a fraction of the time that anybody else had ever done it. Now, ordinarily, you would think this would be good, but the CFO noticed that the amount of hours they could bill was going down. So he said, John, didn't say this to me, but the CTO, Peter, said, I ought to look into this if I know what's going on and see how we can actually harness in various ways. And what did he discover? It shouldn't be a great surprise to this group. Is what happened to these young associates is they were building their own internal Twitter group. They'd just come out of law school. And as soon as they were working on a case and one of the cohort got stumped at the moment, well, what is that precedent we heard about, our first year of law school? Twitters it. 30 seconds later, back comes the answer. And so basically, this cohort had found a way to tap the collective experience or the collective readings of the cohort group, and were able to zero in very fast on what to explore, what not to explore, what cases to pull to read in depth, and so on and so forth. What Peter realized was that this cohort group actually had a new way to work that the senior partners ought to know about. But the senior partners also had a tremendous amount of wisdom that the young cohort group ought to know about. And so Peter saw his role as the CIO, or actually the CTO. How does he actually pull these two groups together and run learning sessions between them, with his being the moderator and the translator and so on and so forth? And that's what's now going on in Skadden. Story 2 is again a large, fairly conservative company, putting it mildly, called SAP. And SAP, some time ago, created NetWeaver, which I think most of us in this room know about. Started out as kind of an interesting design environment, development environment, as an open source environment that sat around the SAP implementations. When they created this, the corporate counsel asked Shai Agassi, can you find a way to accelerate the development of this network, or to get this fairly embryonic system to be fully developed as fast as possible? And what Shai did, working with some other people, is he actually created an SAP community network of developers that actually ended up now scaling to exponential learning rates. This thing started out with 100,000 people. It's now over 1.4 million, probably up to about 1.6 million last time we checked, people playing with this. This turned out to be a very interesting natural evolution if you want to understand how social media actually starts to play out. But how do you actually connect with others? How do you ask and answer questions? And then how do you build reputation? So we can take you through the migration paths that happen. But in fact, as a developer, now, in this network, I can ask a question and on the average expect an answer in 17 minutes. Within 1 to 2 days, that answer will be warranted in the sense that other people have tried it out, validated it, and so on and so forth. So this 2 million person network surrounding the ecosystem of SAP has figured out how to truly turn this experience curve upside down to basically a collaboration curve with increasing returns. My third example is an example that very few of us in this room know about, is Li & Fong. By the way, Li & Fong is not a new company. It's 100 years old, although it certainly refactored and restructured itself for new ways 10 years ago. It's a Chinese company. And in fact, many of the examples that drove John and me to look at these issues came out of studying China, not the Western world. And how is China building agility and innovation into their schemes? Now, if I look around this room, I would say approximately 40%, for me, 80% of what we have on is brought through Li & Fong. They're behind almost everything we wear coming in to this country. It's a pretty interesting company in terms of its financials. It's dealing with apparel. If you know about the apparel industry, it has a very, very tiny margins of 5% or so. But somehow, the way Victor Fong runs this is he is getting a return on equity without playing very many games at somewhere between 30 to 50%. And perhaps most surprisingly, he is getting an average stick-through revenue that sticks with the person, not passing through, a stick-through revenue in China of approximately $1 million per employee. What's going on here? Li & Fong is basically a worldwide orchestrator. They orchestrate thousands. In fact, they orchestrate a little bit more than 10,000 factories around the world. This map just shows some of the factories and some of the countries they're in around the world. Now, what makes them interesting is they are a process orchestrator. What they've created is a loosely coupled but highly modular relational network. By relational network, I mean these guys do not deal in transactions, they deal in long-term relationships with people that join their network. And this network has gone back to Adam Smith, the sense of saying, people in my network are going to be incredibly good because they're going to be extremely specialized. And then I'm going to string together these extremely specialized factories that know how to do particular things incredibly well in order to produce products. Now the catch here is this relational network has to kind of work on the notion of trust. And they build trust, and they accelerate the building of trust by actually a very simple, elegant rule. Victor calls it the 30-30 rule. That is to say that once you join his network, once you qualify, once you have the right working conditions, once you meet the quality specifications, and so on and so forth, once you agree to their protocols, once you agree to use their dashboards to measure performances, et cetera, you come into the network, and they will always guarantee you to take 30% of the output of that factory. But they also say we would never, ever take more than 70%. Why? They do not want factories to feel subservient to them. They also want the factories to be learning from their competitors. And by the way, quite honestly, Victor Fong learns from those competitors too in this scheme. So it's just the opposite of a captive network. It is a network that is meant to be very flexible, incredibly agile, when they can bring new members in a moment's notice, and so on. And it's also a network that actually looks at how do they learn from each other. When things go wrong between two elements in this process network, Victor's company capability brings them together to figure out how to repair the problem. So this network is actually a learning network between different nodes in the network and between multiple providers in that local ecosystem that are part of Victor Fong's network. This is extremely specialized. When he goes to negotiate with Ann Taylor for something, he will say, oh yes, I know there's a certain yarn that's becoming available in Thailand. I know that if I'm going to take that yarn, I can weave it over here in this country. I can actually wash it over here. I can weave it. I can then sew it over here, and so on. And they put together the product through these unique specializations, often using the entire world as their unique spikes to be able to pull this together. By the way, not uncommon to how iPod and iPad are made today, but not quite through these same types of networks. But it's very interesting to see the speed at which these networks get better and better and better. And in fact, it's not too surprising that you don't know of them. But in the Western world, many of us thought that Walmart was the world's best provider of knowing how to deal with logistics and supply chain management. Approximately 5 months ago, Walmart gave up and said, we're doing a strategic alliance with you, Victor Fong and William Fong. We need your help. We need to learn from you how you can be that efficient. And so Walmart has a 4 to 6 year strategic alliance with Li and Fong to pick up their techniques of these loosely coupled networks. Now, by the way, just so you know where I'm headed, you have an ecosystem that's loosely coupled, constantly agile, changing ... Show me an ERP system that's capable of supporting this, where new companies are coming online almost weekly. But let me not get ahead of my story. Let me just say now what we're trying to say is in this big shift, where we're headed, we're going to claim in terms of the need for unpredictability and agility, how do you really take these process networks very seriously as ecosystems of a new kind? And then how do cloud architectures and providers come together to help us play this game? So let's look at this a moment, because I'm going to argue that the cloud is in fact much more disruptive than any of us have ever thought. I'm going to map it out in a two-dimensional space. On the y-axis, what I want to talk about is basically how clouds might first be picked up by groups that have very little IT capability at the moment or investment at the moment, all the way up to those that have huge ERP systems. And before the clouds are going to disrupt those huge ERP systems, especially in the core, not the edge, then clouds are going to have to pick up more and more new types of capabilities. So we see this staircase. But each one of these jumps I'm going to claim leads to a disruption of the industry. The third jump, by the way, will lead to a complete disruption of the IT industry itself. And so we want to kind of walk through these jumps for you right now. Let's start at the simplest one, the one that I think most of us know. And that's simply saying that we know what kind of cloud computing this group surely is. Think about, just from a CapEx point of view, how this actually impacts doing startups or small businesses. Because basically I can go to Amazon Cloud, and by just paying for the use, I can now build a startup at a fraction of the cost I used to build startups at. And in fact, I don't know how many of you raise money or run startups, but what most people don't necessarily realize is the most expensive money you will ever get will be the first money from the angel funding or round A. And it is pathetic to me that the first thing you do with this incredibly expensive money, how much of the company you've given away to get this first $1 million, you dash out and buy IT that's going to be obsoleted in 2 or 3 years. So if you really want to conserve CapEx and keep all the money to OpEx, you want to think about the clouds. And how do you view this as a new type of infrastructure? As not only a kind of a fundamental infrastructure, but I'm going to show you a little bit more that you can actually do with this. In particular, how might you use this infrastructure in order to scale very fast? So I want to look at one particular case study using the Amazon cloud. Anamoto. Anamoto is a company, small startup, has a very clever offering. You submit your pictures to Anamoto, and it analyzes them with some fairly smart algorithms, and then basically it composes a music video for you. And it lets you download it, or it lets you play it. And if you don't like it, fine. Just tell them, they'll do it again, and they do it again, until you find something you like. At that point, you download it and you pay for it. That's simple enough, although, by the way, the algorithms that do the picture imaging and parsing are not quite so simple. And then one day, they posted this app on Facebook. In the morning of that posting, they were running approximately 50 servers on Amazon. Within 24 hours or so, they had shot up to 5,000 servers. The Amazon cloud provisioned on the fly servers from 50 to 5,000 in one day. Now, no one could afford to have been able to over-provision their operation that much. And if basically Anamoto had not been able to serve the needs of those customers, few customers in today's fickle world come back. And so this sense of infinite speed to scale up made all the difference in the world. And they didn't have to pay for any of the stuff that they weren't using. By the way, the amount of servers they use now have come back down to somewhere around 2,000 to 3,000, but still, I'd hate to have to pay for those up front. Now, did Amazon Cloud do that by itself? Actually, the secret is no. Amazon Cloud had another startup called RightScale up the road in Santa Barbara that actually provided a management layer as a service layer on top of the Amazon Cloud that sat between the Amazon Cloud and the software as a service that Anamoto had built to actually facilitate the management of this radical scalability. So what you're beginning to get a sense is that Amazon is actually building an ecosystem of services by third parties, that also startups, by the way, that then feed into other startups using this type of system, back to the collaboration curve of exponential power. Let's look at a simpler example. Consider the small business web. Small business web was created a few years ago by just getting a half a dozen small startups together and said, why don't we just agree amongst ourselves, pardon me, to kind of open up our APIs. So if you use this, then the person who uses your services can also use my services fairly easily. No sophisticated compositional structures between these services. Just make it so I can get access to them and I understand the quote-unquote APIs for this. And this small business web caught on very fast. And now there are many, many more companies that are joining this. This is kind of the simplest kind of example of the cloud. And in fact, I got interested in it because if you consider Salesforce.com, Salesforce.com was a total disruption to Siebel CRM systems, et cetera, et cetera. But now, Salesforce.com, 2 or 3 years later, is being disrupted by this. So the small business web is disrupting Salesforce.com that disrupted the more standard players. That gives you some sense of the speed of things are happening. But Salesforce.com is not asleep. And they're now building all kinds of services on top of their quote-unquote cloud so that people can start to use their services, or third parties can provide their services on their platform. But it's still interesting that that platform does not really facilitate letting you compose the services, just use them in terms of APIs. So let's switch to Amazon. I don't know how many of you follow Amazon. Almost every morning I wake up, I find that they've added some new fundamental service to the Amazon cloud that any of us can use to do things. And that's not quite too surprising given Jeff's commitment to cloud computing. But here's just a list, and there are approximately 700 or so companies now that are putting services on the Amazon cloud that you can decide to use in building your own new service. This is a tiny sampling of the kinds of things that are happening. And so you're finding ecosystems that are beginning to explode around these systems. But let's move on. That's the obvious use. I think everyone in this room would know how to build a small startup in a moment's notice using that. The second level up is saying, what are the unmet needs that ERP systems can't service, that are coming now to become fundamental drivers of the way that our economy is going to move? Lian Fong was one of the examples, which we'll come to. I want to talk about a very small company, no longer quite so small, Reardon Commerce, up in Foster City. Reardon Commerce is an intelligent travel agent system, automated one, not really an AI system. It was basically a web-facing, simple system. But it caught on. Caught on now, so approximately 4,000 companies that are using them. They're serving 2.8 million people. I would guess half the people in this room, either directly or indirectly, ended up having their travel agendas organized and orchestrated by Reardon. They're dealing with 160,000 providers and 60 partners that do reselling of their services. They started out basically this very web-facing service. But to be able to play this game on the fly as the system is running, as Jamie was saying, they had to completely refactor the system to a true service-oriented architecture, true cloud-based system that had some very interesting properties. The most interesting property So basically, they were running an equivalent to a 3-tier architecture initially. They had policy spread all through the system. And what they really had to do to make this system scalable, I'll explain why in a second, they had to factor all the policy out, no matter where it was touching the code, get it out, make policy a first-class object that had extension points that the policy engine could grab, but more importantly, that every one of their companies could grab. In their new system, basically any company sets up the policies on the fly, can change those policies on the fly that go into the policy container that then the policy engine uses in order to structure the particular trip that you want. So now, in some sense, although this service runs kind of in the cloud, each company has what they care most about, total control over the policies, because they manage the policies. Once they get totally torn out of the system and made first-class objects. Now here's the catch. If travel was a simple conversation or a simple transaction, no sweat. But most of us are traveling complex trips. Here's a complex trip. I'm going to call it a long-lived conversation with multiple points of coordination. Going from San Francisco to JFK, from JFK to Orlando, to Chicago, blah, 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 blah. And lo and behold, the flight, if you're used to flying out of New York, especially LaGuardia, to Chicago, good luck, it got canceled. And suddenly the whole trip had to be replanned. This is the beginning of a long-lived conversation. By the way, think about it a moment. Some of these trips can last a very, very, very long time. Suppose a company changes the policy in the middle of a long-lived conversation. How do you want to do that? Well, guess what? Policies have to have version numbers. And so once a trip is started, that version gets time-stamped, and that conversation is allowed to run through according to that. But every new one that starts gets the latest version. Interesting thing here is that basically by factoring policy out in terms of a new type, I'm going to call it an interaction server, policies are now operated on by constraint engines. And the constraint engine looking at those policies is actually capable of, when something goes fundamentally wrong, you have a major exception condition, of figuring out on its own what to do. This is a new kind of workflow, not a directed graph, but one that actually can reconstruct the workflow on the fly depending on the exception condition. Now, that's pretty cool. It's actually not that complicated for this kind of a system. But let's go one step further. Suppose I really have, like Li and Fong, 1,000, let alone 10,000 companies in my ecosystem, each with their own policies, each with their own notions of how work should get done. Am I going to build a workflow that sits on top of 10,000 different companies? Say alone, even 10 companies? Probably not. So what we're really saying is if we start to support these ecosystems, we've got to look at this world a little bit differently. In fact, I think it's fair to say the more you move to an ecosystem, unless you are a gorilla that dictates how everything's going to happen, then you have multi-party interactions that get very complicated. The EAI style that we're used to ain't going to work. And basically, you're going to have to find a way to externalize policies so that basically those can be picked up remotely by the providers of those or the owners of those policies, but nevertheless used in these kind of constraint-based engines. So we're finding, by looking at these companies in China, they're engaging a lot of new ways to organize. I'm going to call this new forms of institutional innovation. And we look at consumer electronics, by the way, where your iPod is made. Motorcycles, China now dominates the world in making motorcycles. Apparel, I just talked about Li and Fong. What we really see is these new generation or you might call it the new normal of doing things in terms of these ecosystems, really have these capabilities of basically radical specialization, world-class capabilities in terms of those specializations, flexibility, rapid learning, and so on. In fact, when I used to work for Xerox, we talk about bringing a new idea into the company that may actually change the way we manufacture something or some of the specialties we have, let alone the way we sold things, et cetera, et cetera. Well, they would say, John, no, we can't bring in a whole new sales force. No, we can't bring a whole new set of engineers. No, we can't build a new factory. When I went over to interview Victor Fong originally, and I said, you know, Victor, some of us are getting very interested in nanofiber, which is a new way to build very interesting material. How are you going to understand how to kind of now upscale your entire network to be able to know how to find it, source it, weave it, dye it, and so on and so forth? He looked at me as if I was from the Stone Age. He said, John, what are you talking about? I can do that in a day. Because basically my network is loosely coupled modular networks, and I have no inertia there. I can find these people on the edge and bring them in instantaneously. I don't have to worry about not invented here syndrome in this type of network. Whereas in the Western companies, which we are driven by supply chain, fixed supply chain, and so on and so forth, these systems are in fact very efficient, but basically very unflexible. One of the best supply chains I work with is Toyota. No comments about their problems right now, but I mean, Toyota has learned how to turn their supply network into an innovation network. But it's very tightly controlled, it's very limited, and so it's kind of, they've gotten the best out of a fixed set of assets, as opposed to what Lian Fong does, to be able to bring in unlimited number of new types of experts and capabilities as they go. So what we're really saying is, in this new normal that Jamie and Chris are going to talk about, we're going to shift from basically in-out architectures that all of us in this room have built, and in-out architectures, we build it for ourselves, and then as an afterthought at best, we set it up so that we can actually get partners to be able to interact with it, but it's basically us first, and then them, and basically that's the way we kind of architect these systems, for good reasons, by the way, to a different class of architectures. I'm going to call them outside in, which really start with the notion of an ecosystem. And here is the catch. The architectures that we in this room build today are basically very chatty, fine-grained architectures. The apps are talking all the time, very low level. It's a very chatty type world we build for ourselves. What we're claiming now is the out-in architecture raises our concern to a much more granular system, looking more at the level of business documents, where the real business actually happens. In these types of service-oriented architectures done right, in these out-in architectures, then you have the chattiness is around business documents at a very high level. When you have exception conditions, then it's very easy to look at what went wrong and how to fix it on the fly, which is not true if you're really doing these very fine-grained, chatty types of interactions between app servers. The third level is where you start to see a new set of disruptions of the IT industry happening. In some sense, up to now, the cloud providers are kind of obvious. They're going to be things like Amazon that built their cloud for other reasons. So they had adjacency, Microsoft, Google, Salesforce in a way, and so on. But here, we want to start to tease apart, in fact, a shift from these vertically oriented cloud providers that kind of integrate infrastructures at the bottom, enabling software, enabling platforms, all the way up to software as a service, and say, maybe kind of like the PC game. The PC game used to be highly vertical, but now, very quickly, it became a set of horizontal players. Might this be happening where we're headed now with clouds, where we're going to find a new type of layered structures of competitors at each particular level in the cloud. Hard to tell yet, but what I want to kind of draw attention to are a couple of possibilities that are happening. Now remember, I started off about how do we move from a world of stocks, things that kind of stayed stable over long periods of time, to the world of flows, where change, flux, is the only thing to be expected. Well, in the world of constant disruptions, I don't know how many of us have thought about it, but when we build relational database architectures and build gigantic relational databases, that depends on schemas. Most of our schemas have been defined 10 years ago. The schemas define kind of, in terms of the columns, the ways we want to talk about the rows, in terms of the product we produce, and so on and so forth. It's not that easy on a moment's notice to go in and change a schema. Sure, I can build a new database, I can do joins and things like this, but relational databases actually gain their strength from predictability. But in a world of zero predictability, that very strength becomes a weakness. So it's an interesting question. How might we take the SQL point of view and now take it to what you might call the no SQL for things that it is great at, and then augment it with the SQL? And lo and behold, this is an interesting way to look at what you can now do with MapReduce and Hadoop. The key here, especially as we move to huge amounts of data, and by the way, don't forget, data has tremendous inertia. When you're dealing with petabytes of data, that's not something you just decide to FTP to somebody. The abstractions that at least I grew up with, and many in this room, is in the past, we got used to bringing data to the computer. That was the fundamental abstraction. I want to argue that in these massive databases, we may want to again flip that and ask the question, how do we bring the computer to the data? Now that is exactly what MapReduce enables us to do. It's not the way they talk about it, but suppose I have this giant database, and suppose what I want to do is say, can I take 1,000 or 10,000 very cheap machines and have each machine look at a fragment of this database, a very small fragment, and how do I coordinate these 100 to 1,000 to 10,000 machines so they work on this distributed database, and then take the partial results from that and almost on the fly, construct a schema through the reduction operator that then I could push it into a relational database if I wanted. Might I have the best of both worlds? Well, let me tell you, this is non-trivial. It's non-trivial because, first of all, you can't count on the reliability of these machines. You can't count on the reliability of these databases. You got to put redundancies all over the place. You got many, many small disks with partial copies of your segments of your database. How do you know which segment I want to trust? How do I actually update these things? If I have a distributed file system, folks in this room surely know it sounds great until you worry about concurrency, until you worry about consistency across the entire database. Guess what? In this world of Hadoop, you don't have consistency. Not in the obvious sense. You might have eventual consistency, but not consistency. You get fantastic performance at the cost of consistency. And by the way, since these machines are always breaking, how do you factor that into the algorithms you want to do? Now, it wouldn't be hard for Chris, Jamie, and I to stand up here for an hour and talk about that single problem. Fortunately, I think you have a track on this topic. But I think one of the most interesting issues right now is how do we rethink database and storage that gets incredibly high performance on massive databases where you don't quite know ahead of time what you want. And I got into this game for a bizarre reason, because I do a lot of work with intelligence communities. And there they have huge databases, and believe me, they don't know ahead of time what's going to be important. So they got to be able to sort through petabytes of data blindingly fast when they just decided, oh my God, there's a different structure out there. No, I don't have time to build a new schema and update my 5 or 10 or 20 petabytes of data. I got to look at this problem completely differently. I claim that's more and more the case with us. And when it's not the case, then you complement it with an SQL database, and you see how these two things play. Let me talk about one other change. Graphic processing units, another game changer. I alluded to at the very beginning. Today, now on a single chip, through NVIDIA, we're getting 512 processors. And by the way, I can take a 512 processor box sitting on a cheap Dell server, and I can build this entire thing for $2,000. But why would you want to be satisfied with just 500? Why can't you string 100 of these boxes together? So now I have basically 50,000. Now, graphic processing units are fantastic for certain kinds of things, and they're terrible for other kinds of things. And there's a secret. To be able to exploit a GPU, guess what you have to do? You got to feed it data blindingly fast. Guess what? That doesn't fit into the cloud architectures very well. Well, this is being thought about. And so you're finding certain cloud providers beginning to say, I got to change my architecture. How do I pipe and cache data into these GPUs and figure out how to give you access to GPUs? Let me give you an example. 6 months ago, obviously 6 months ago, a poor half-witted machine, 250 cores, and my friend of mine who works in the financial industry sent me this note. On a standard Linux box with a single card running 250 cores, I did a 1 billion path, that's billions, 1 billion path Monte Carlo simulation that took less than 1 minute. You want to talk about risk assessment or material science, checking out the life of a property? That's what you use. Stan goes on to say, I have never, and remember, and this is truly true, I have white hair, seen a 1 billion path simulation attempted on anything, let alone a box that cost $2,000. And that just doubled to 500 cores a couple weeks ago. And that's the basic building block if we wanted to start scaling these things together. This is another kind of game changer. This enables me to, for example, do material science in a brand new way. This enables me to do science calculations of a certain class in a brand new way. In fact, Google was pretty slow to understand how this could disrupt certain of their uses on the cloud. In fact, you might say, I can go down to Fry's, as my next door neighbor did, and buy a couple of these boxes and use that to augment my own use of the Google Cloud. Let's move on. Finally, the fourth disruption is the disruption of non-IT industries. How could this be? Let's look at them. Basically, we're used to software as a service, but what about, so much for lasers, okay, creating business as a service, a platform for providing common services to industry players. I want to look at 4 briefly and come back to health. Think about healthcare, think about financial services, think about energy in terms of how do we want to think about smart grids, and how could that be a business as a service? And of course, media, which by the way also comes back to thinking about Hadoop and new ways to build some of these massive search engines over cached cloud fronts, playing these things out. Let's look at healthcare. Might it be possible today, using the cloud, to build a healthcare system that is designed to serve 200 million people simultaneously? Might you be able to use Facebook as a front end? Might you be able to actually use Microsoft Vault system, Health Vault system, as a back end? Well, everyone in this room would say, give me a break, John. You got to build adapters galore. Every hospital has their own ways of doing things. They're wedded to Epic systems, ... which is true. By the way, there's also something called HL7 version 3 that's now slowly being adopted, so that basically every instrument in the hospital generated its own event on an HL7 bus structure. But the catch is, what's happened in the last 6 months is the federal government, being driven by actually a guy named Brian Benioff, who is the founder of Apache, has created an open source connected, what he calls community portal. They have established with the government for all the hospital systems that the government uses, kind of an open standard that they're going to make these hospitals play into. And they're building connectors to virtually all the major hospital systems. That means that we have a set of connectors being built that now says what's left open is the core, what's sitting in the center in terms of this out-in architecture. We believe that you're going to see an incredible disruption, not only of the Epics of the world, of the IT industry, but how we're going to be able to now build something that actually builds a unified version that actually talks to not only the hospitals, not only the doctor's offices, not only the pharmacies, not only the testing centers, not only the cancer centers, and so on and so forth. They're bringing them all together, combining this kind of capability, this kind of thinking, and so on. I'm sure it's going to be 2 or 3 years. What's surprising to me is using cloud architectures. We're now very close to finishing a reference implementation that somebody could do this. That's not a full implementation, but it is a reference implementation. And so I think it's just an example of how we're positioning ourselves for some major disruptions of how entire industry segments actually operate. So let me end with 2 brief comments. What we really see is a movement from the Enterprise 1.0, Enterprise 2.0, everyone in this room is totally familiar with, to what I'm going to call kind of an Enterprise 3.0 that really is driving this notion of out-in architectures, cloud computing, but built fundamentally on policies as a first-class objects, which enable us to handle asynchronous, long-lived conversations, the bane of our existence for half of us in this room, but also looking at the notion of service grids that enable us to harmonize policies and SLAs across multiple clouds so we can bring multiple clouds together. But the key, which is another session here, is on top of all this, there will be exception conditions. Any straight-through processing technique we use, going across even the silos inside an enterprise, let alone across ecosystems, are going to always be running into trouble. The policies aren't right, the rules aren't right, always kind of edge cases. And in fact, the dirty secret is, my guess is, probably 80% of our time in this room is actually spent handling exception conditions. What we haven't talked about, but you will this week, is how might you use social media as the additional layer so that when you hit an exception condition and capture the stack especially if it's if it's a coarse-grained around business documents, to be able to pull all the relevant people together on a moment's notice to resolve that breakdown, that exception condition. So I think we're going to find that no, even with constraint-based systems, et cetera, there will be exceptions. And how do we now use social media as a very simple layer on top of a much more sophisticated layer that lets us be able to modulate and moderate those types of exception conditions? I think it's an interesting question to think about as you leave this conference. So with that, let me just say, the world we're in, it's a world of rapid evolving, and I'm going to call it a true coevolution between digital infrastructure and the structure of industries, and the structure and the form of these ecosystems more generally. We got to get beyond thinking of the firm into the ecosystem. We now have the tools. We're beginning to build the protocols. The cloud provides us not only agility for within the four walls of our firm, but now to enable us to think outside the firm in some very interesting ways. So I might suggest that yes, there really is a new normal, and are we ready for it? And perhaps more importantly, can we shape it? Can we shape it so it actually is a form that enables us to gain competitive value? Thank you.